So I hope you had a good time practicing yesterday converting between degrees and radians, because those conversions will also help us with a lot of videos to come. For instance, even if we're not converting as much today, we are going to be focusing on something that some of you might remember from geometry, complements and supplements of an angle, and we're going to do that in both degrees and radians. So again, it is good to know how to convert between them. Now, let me remind you of a few things. Wait, before I do that, some of you might be wondering, why is this in red here? That's because when I made the packets, I realized I had a little copy-paste error. So at this time, if you could change the title of this video to complement and supplement of an angle, instead of converting from degrees to radians, because we just did that the last time. So let me give you a minute. Please change that title. All right, thank you so much. So a couple definitions that you are probably familiar with. Acute angle. In degrees, that means it's between 0 and 90. Obtuse angle, defined as between 90 and 180. The complement of an angle, or complementary angles, remember, means two positive angles, positive being important, whose sum is 90 degrees. And supplementary angles are two positive angles, whose sum is 180 degrees. So you might notice that, yes, all of these definitions are in terms of degrees, but also you need to know them in terms of radians. Some of you might be asking, where did this pi over 2 radians come from? Well, let's think it through. We know that in one revolution of a circle, there's 2 pi radians. We also know that if you go halfway around the circle, that's pi radians. So if you go even another half of that, that's where you get pi over 2. Or visually, if you think about a circle, we start at 0. If we go all the way around the circle, we end up at 2 pi. We said that halfway around the circle was pi, so the distance between 0 and pi would be half of pi, or pi over 2. So pi over 2 is equivalent to 90 degrees. So that is really good to keep in mind. So if we look at the definitions, acute makes sense that it's between 0 radians and pi over 2 radians. An obtuse angle would be between pi over 2, or 90, and pi, 180. Complementary angles whose sum would be 90, or pi over 2. And supplementary angles whose sum is 180, or just pi radians. So you can keep looking back up at this for a reference for the problems we're about to do. If it exists, find the complement and the supplement of the given angle. So, degrees first, to get those definitions back in our heads. If we're looking at 72 degrees, I want to find the complement of that angle, and I would like to find the supplement of that angle. The complement of 72 means the angle that adds with 72 to get 90. In other words, to find the complement, we could take 90, because we know the sum is 90, minus 72, and get the angle, or the complement angle, to be 18 degrees. Supplement, we can use the same relationship. We know that supplementary means two angles whose sum is 180. So if we took 180 minus the angle that we know, 180 minus 72 is 108 degrees. You could always check your work. You could take 108 plus 72 and see if it's really 180. You can take 18 plus 72 and see if the sum is really 90. Example 2. We want to, again, find the complement and the supplement of the angle of 103. So first, I'm actually going to do the supplement first. If we took 180 minus 103, if we took 180 minus 103, we would get that to be 77 degrees. So again, feel free to check. If you take 77 plus 103, you should get 180. However, the sum of two angles that are complementary is 90. If we take 90 minus 103, we technically get the answer of negative 13 degrees. But if you think about that, can I have a negative angle? Could I have a negative angle in geometry? The answer is no. So the reason why the directions say if it exists is sometimes you're going to get something that you can't have a complement or you can't have a supplement. So this doesn't work, so I'm going to say does not exist. Moving on to 5. Now, 5 doesn't have a unit, so I'm assuming it's in radians, which means that now I'm going to be using 2 pi, pi, or pi over 2. I still want to find the complement. I still want to find the supplement. This time, for these two examples, we took 90 minus, but now that we're in radians, it's going to be pi over 2 minus the current angle, because pi over 2 is equivalent to 90 degrees. Now, this answer is, because the directions say leave the answer exact, it's almost correct, except because this is technically a fraction, this is really 5 over 1, so we would need to find a common denominator. So if I wrote down the problem, pi over 2 minus 5 over 1, the common denominator is 2, which means that this second fraction would need to be multiplied by 2 over 2 to get the same denominator. So we'd have pi over 2 minus 10 over 2, which we can combine to be pi over 10 all over 2. So that would be your answer as an exact radian. The supplement of 5, you would think the same type of logic. The 180 degrees in terms of radians is just pi. So you initially would say, I'm going to take pi and subtract 5. This time, we don't have any denominators, or the denominators are both 1, so we don't have to get a common denominator. So the answer is just pi minus 5. And yes, these are technically decimals as well, but I asked you to leave the answers exact. The final example, 5 pi over 6, we still want to find the complement, still want to find the supplement. So the complement of 5 pi over 6, let's see. So complement means adds up to 90, so we're going to take pi over 2 minus 5 pi over 6. We definitely need a common denominator here. The common denominator between 2 and 6 is actually 6, so this first fraction would have to be multiplied by 3 over 3. Do that in purple. So 3 over 3. So we would have 3 pi over 6 minus 5 pi over 6. 3 pi over 6 minus 5 pi over 6 is negative 2 pi over 6, which is really negative pi over 3. Now, if anyone's looking at that and second guessing themselves or thinking that might be a problem, you are correct. Because just like in example 2, when we had a complement that didn't exist because it's negative, because this answer is negative, does the complement actually exist? No, it does not. So you would write does not exist. So we can't find a complement of 5 pi over 6. However, if we would like to find a supplement, we would have 180 minus this, or really pi minus 5 pi over 6. Pi is technically over 1, so my denominator would be 6. So I'd multiply this by 6 over 6, get 6 pi over 6 minus 5 pi over 6. 6 pi minus 6 minus 5 pi over 6 is just pi over 6. So this one does have a supplement but not a complement. So it is possible that sometimes you will not get both. With that in mind, on the next slide, these are all for you to try. Similar ideas. So please, I would like you to pause the video. Please try as many of these on your own as possible, because the best way to learn math is to try it yourself and then correct mistakes. So please pause the video now. When I come back, I will have all of my work so you can check your answers. All right, guys, here's my feedback for you. 55 degrees, I found that the complement 90 minus 55 was 35 degrees. The supplement was 125 degrees. Example 2, I tried to find the complement, got negative 25, so I said the complement does not exist. The supplement I got to be 65 degrees. Example 3, the plain old 1, which you assume is in radians. For the complement, I did pi over 2 minus 1 originally. Notice then that this needed a common denominator of 2. So I multiplied the second one by 2 over 2, and then combined to pi minus 2 all over 2 for my final answer. The supplement would just be 180, or pi minus 1. And then there's the last one, the good old last problem where you have 3 pi over 7. If I wanted to find the complement, that's really pi over 2 minus 3 pi over 7. The common denominator is 14, so I had to multiply this fraction by 2 over 2 and this fraction by 7 over 7. So I got this to be 7 pi over 14 minus 6 pi over 14, which means that my complement would be pi over 14, so it does exist because it's positive. The supplement is initially 180, or pi minus 3 pi over 7. Common denominator we need is 7, so I multiplied pi, or pi over 1, by 7 over 7. So I had 7 pi over 7 minus 3 pi over 7, which is equal to 4 pi over 7. If you got all of these right, great job. If there's something that you need to correct, please do. You can always go back and rewatch this if you'd like to. All right, guys, until next time, good luck tomorrow in class.